In this video, I'm going to teach you how to do sigma notation given the series. So we got this series. Now the first thing which I want you to notice is number 1, which is 1, which is, it's funny, but yeah, whatever. But like you got 1, 1, 1, 1. So like 1 is a constant in the pattern. So what you want to do is whenever you get like a constant like that, you know for a fact. Now, okay, so you need the equation now. Okay, firstly, when writing a sigma, now I suck at writing sigma, but it's like a 3-shaped thing. Yeah. So whatever this, so if you're making the equation in terms of n, it'll be n is equals to. It'll be always number 1 when making a sigma notation, and the last number over here is the number of this, right? Now we know this is number 1, this is number 2, this is number 3, but we do not know what's number 4 here. But we will know it because we're going to get an equation, right? And we will make it equal to this, then we get what's the number, the position of the term. So to get this equation right here, which we're going to do, it's simple, right? Because 1 is a constant right here, I'm going to just put 1, okay? 1 over. Now somehow I need to turn 15, 17, 19 into a pattern. So if I do it separately, right, 15, 17, so let's see, 17 and 19. Now 15 and 17, the difference is positive 2, 19 minus that, this minus this is 2. So you know this is a linear function, this is an arithmetic pattern, so it equals to, so the pattern, like Tn, is equals to this 2n plus, what is this minus this? So 15, the first term minus the constant difference, plus 13. So these numbers 15, 17 and 19 can be written as a pattern. So in brackets, because we're saying this number times this number, so 2n plus 13 plus 13, and then times another brackets, but now we need what's this called, we need this 19, 21, 23. So 19, 21 and 23, 19, 21, 23, difference of 2, so we know the pattern will be 2n. This term minus this term, that's 17. So 2n plus 17, and you can test all this. Put 1 in the equation here, you get 19. Put 1 in the equation over here, you get 15. So it's 2n plus 17, so 2n plus 17. Perfect. So we got 1, we got this pattern here, we got this pattern here, but the problem is this, right? Can you see how the alternate numbers are negative? So like negative, plus, and it goes on. Anytime you get that, all I want you to do is put a bracket in front of the pattern, put minus 1 to the power of n, and then obviously times this. Now why is this? Think about it, right? If I say minus 1 to the power of n, if I put the first pattern, that'll be minus 1 times whatever number, right? So you get minus x. And then obviously after 1 becomes 2, but minus 1 squared, it's 1. So that the next one be x, and then minus x, and then x, then minus x. So that is why when you put 1 in the equation, it gives you minus this whole thing, which is this. Then it's plus, minus. So anytime you get alternating, you put this minus 1 to the power of n. Now we're almost done. We just need this number. But now think about it. Now to get this, we need to equate this whole pattern over here to this whole thing. But think smart, right? Think really smart. Instead of equating this whole thing over here to this, we can just equate like 61, for example, to just this, right? Because we got this pattern for the 61 only. So we can just say 2n plus 17, because this represents the second values over here, all these values, which is equal to 61. Then 2n is equals to 61 minus 17, that is 51. 51 minus 7, 50, 49, 48, 47, 46, 45, 44. And n is equal to 44 divided by 2, which is 22. So there we go. It's a 22nd. And once again, you can retest this. Put 22 in this thing and see if you come to 57. 22 times 2 is 44. 44 plus 3 is 57. Actually, no, wait. 44. 47. No, that's wrong. So let me just review this quickly. Oh no, wait, I'm sorry, I'm right. This is not 2n plus 3, it's 2n plus 13. There's a 1 here. So obviously 2 times 2 is 20, 22 is 44, 44 plus 13, it's 55, 56, 57, right? So this answer is correct. Therefore now you put your 22 over here. And there we go. This will be your final answer. Remember to show all your workings.